Today we'll be looking at water balance. So we'll be looking at how to use the water balance equation to solve problems. So we'll be taking a sample problem. So the question says a catchment drains an area of 11,834 kilometers square and the average discharge is 144.5 meter cube per second, while the average precipitation on the catchment is about 1080 millimeter per year. Find the evapotranspiration. Okay, so whenever we are given a problem on this, the first thing we do is to get our parameters that we are given in the problem. So from the question we are given area of the catchment, the discharge, which is also the same thing as the runoff. We have our precipitation, and we are asked to find the evapotranspiration. Now, for this case, we have our water balance equation to be P minus ET, which is evapotranspiration, minus our runoff, which is the same thing as discharge, to be equal to 0. So our evapotranspiration, ET, is going to be equal to P minus R. Okay. Now, evapotranspiration is given in millimeters per year or millimeters as per month and otherwise. Our precipitation is directly given in millimeters per year, but our runoff, which is our discharge, is given in meter cubes per second. So our task here is to get our runoff in millimeter per year, and that way we can directly get the value of our evapotranspiration. Okay, so what do we know? We have our area to be equal to 11,834 kilometer square, and we know that 1,000 meters make 1 kilometer. So this is going to be equal to 11,834 times 1,000 meters square. So we are going to have our area in meters square to be equal to what? Times 10 raised to power. Okay. So after getting the value for our area in meters square, the next thing we get, since we are considering the catchment with respect to a year, we get the value of our seconds in year. So how many seconds do we have in a year? So we simply have 60 times 60 times 24 times 365. So this is in minutes, in hour per day, and in a year. So this is going to give us 3.15 times 10 raised to power 7 seconds. Okay. So we have gotten the value of our area and the number of seconds in a year. Now we know that our volume, okay, which is measured in meter cube, is simply equal to our area times depth. So we have our runoff in millimeters per year to be equal to 144.5 meter cube per second times our number of seconds in a year, 3.156 times 10 raised to power 7 seconds. I'm coming. Okay, we have our area. This is per year, and then we have our area to be 1 over 1.183 times 10 raised to power 10 meter square. Okay, so this takes away this takes away this. So we have our runoff in millimeters per year to be equal to 144.5 meters times 3.156 times 10 raised to power 7 per year times 1 over 1.183 times 10 raised to power 10. Okay, so what do we have? So what do we have? So what do we have? 0.38549 meters per year. Okay, but we are looking for our runoff in millimeters per year. So what do? We simply multiply. Remember, to convert meters to millimeters, we multiply by 1000. So our runoff in millimeters per year is simply equal to 0.38549 meters per year times 1000 millimeters per meter. So this cancels this. So we have our runoff in millimeters per year to be what? 385.49 millimeter per year. Okay. So since we have been able to get our runoff in millimeters per year and we have our precipitation in millimeters per year, we can then go ahead to compute for our evapotranspiration. So we have our evapotranspiration ET to be equal to precipitation, which is 1080 minus our runoff, which is 385.4. Hence, we have our evapotranspiration to be what? 694.6 millimeters per year. Okay, so that is how to get our evapotranspiration when we are given our precipitation on and our runoff. So it's basically reducing the units to the required units for our parameter that is needed to be found. Okay, that's all.